In this video, we'll talk about augmented matrices and row operations, kind of what they are, how we would use them, and then this will build the skills that we would use to solve systems of equations using a matrix. So let's talk about what an augmented matrix is. So an augmented matrix is a way of which we can write a system of equations. And the way that it works is that I will kind of denote in the matrix where the equal sign would be within the matrix itself. So if we're looking at this, usually how we define it, and we're talking about a matrix where everything kind of has to be agreed upon. And usually how it works is the first column will be the coefficient of my x variables, the second column will be the coefficient of my y variables, and then if I have any more variables, because like we're with an augmented matrix, we would usually use these to solve systems of equations where we have 3 or more unknowns in just as many equations. So I'll do one here with just 2 equations, 2 unknowns, that way it kind of looks a little bit familiar. But the idea is we're going to transfer this into a matrix, and the idea is we're going to look at the coefficients. So if we're going across the top row here, we're going to have 3, 2, and then we will have the constants on the other side of our equal sign, so 7. So this means 3x plus 2y equals 7. That'd be the first row. So the second row will have negative 4. Technically we have a 1y, and then we'll also have a negative 2 for our constant. So when we go across the row, we'll have negative 4, positive 1, and then a negative 2. So this is how you can convert into an augmented matrix. And we'll talk about how to use this here in a minute, but there's a couple other things we have to talk about first before we can use this to solve. But an augmented matrix is just basically a matrix that's representing an equation, or a series of equations in this case. So let's talk about row operations. There's 3 things we can do with rows. And we can also do this in any combination as well. So we can do more than one of these things, but there's only 3 operations that we can do. We can switch rows. And I'll show an example here on another slide here in just a minute. So we can switch rows. We can add or subtract rows. Or we can multiply or divide a row by a number. So these are 3 operations. I'll show you what you can do, and then in a separate video, just for the sake of length, I'll do an example of solving a system of equations with these row operations. So let's talk about the first operation. The very first one I can do is I can switch rows. So in this case, I'm only looking at one where we have 2 equations, 2 variables, just for the sake of simplicity here. So I can theoretically switch the order of these 2 rows, and I'm not changing the system of equations, I'm just giving them in a different order. So I can say R1 switch with row 2. There's a little bit of a nomenclature here, and then I will put the result in another matrix to the right of the one where I start with. So instead of having row 1 is 1, 2, 3, that'll become row 2. And then we'll have our dotted line in between the 2 and the 3. And then likewise, 4, 7, and 12. Now this can be useful for if we want to have different numbers on the top row of our equation, or of our matrix. And we'll kind of talk about some benefits to having that when we go through an example of how to solve a system of equation with matrices. So the second operation we talked about was adding or subtracting rows. So what you can do here is you can add or subtract 2 rows, which, let's say hypothetically we take row 2 plus row 1. Now what's happening here is really what I'm going to do is I'm altering row 2. That's what I'm denoting here. And the reason we would do this is if you think about elimination, we're looking at this y column. If I add these 2 rows together, those y's will cancel, giving me an equation with just x's. So we can walk through an example there. We're going to add 2 and 8, and we'll get 10. 4 and negative 4 makes 0, and then for the last one, we'll also have 10. And then I'm going to leave the first row as is. Now, the benefit of doing this is that I'm looking at this, and what this last row is really telling me is that 10x is 10, which means x is 1, and then theoretically I can plug this back in to this equation, which is really 2x plus 4y equals 3. And then we can go from there, do some subtraction, solve for y. So usually when you're adding or subtracting rows, you're trying to get one of them to cancel out somewhere. You're trying to cancel out a variable or possibly even 2 variables, if we're talking about a situation where we have 3 equations with 3 unknowns. So we can do that, very much doing the elimination step if we're thinking about elimination. And you might be asking yourself, why in the world are we doing this with 2 variables, 2 unknowns? And realistically, you wouldn't do this with 2 variables and 2 unknowns. However, if we're talking 3, 4, 5, 6, and just as many equations, this is where the matrix really starts to shine. So let's say I have a matrix, and let's say I have eliminated an x, just for the sake of the sake. So if I'm looking at this, like, yes, we could say 4y equals 16. Or what I could do is I could take either row 2 divided by 4, or I could say 1/4 times row 2. Both have the same effect. I'm only altering the second row, so I'm going to leave the second one as is. And then I can divide this entire row by 4. So then 0 divided by 4 is still 0. 4 divided by 4 is 1. 16 divided by 4 is 4. Now this tells me y equals 4. Now that's just one example of how it can be useful. Sometimes we'll want to have a coefficient. So like, for example, we'll want to have a 1 up in this top left corner, and we'll talk about why that is when we talk about solving a system of equations with elimination. Or not with elimination, with a matrix. And this is just one of the things you can do. You can scale up an equation or scale it down. This is very much like a multiplicative step in systems of equations when we're using elimination. So a very similar idea. Basically, we're using a matrix, and what matrix will allow us to do is do elimination, but do it much quicker and more efficiently.